So I'm going to be away. Actually, I'm going to be away just for 1 week. The next week, I'm going to just be preparing for the next portion of the class. But I strongly suggest that you guys try to do things around this stuff. And let me tell you, there are several things which could be done. One thing which Ryan wants to do, which is to implement all these algorithms in Java and Python. And people could be collaborating with Ryan on this activity or whatever, because it's interesting to see how, oh, by the way, if anybody knows Haskell, Fortran, whatever, because it is very instructive. Right? Second project, which I was planning to do here, but it's, will never be done, is if somebody could find time. The question is, when is the optimal algorithm make sense? What is the cost of the function? What is the cost threshold which makes this really compelling? Right? Sort of try to figure that out. And the third project, for which I would be extremely grateful, is actually try to improve all of the code which we got. So whatever we have in lecture 10, sort of, you could try to improve this left-right list thing with maintaining one list. Somebody could try to improve the pool. Somebody could try, again, do not view the code which I have as in some sense final. I mean, so try to improve on it. I will be very, very happy to see the improvements, and then maybe we will just literally discuss the improvements in the class. Right? So, because this is sufficiently complicated code that you could come up with a different. I chose a path, and as far as I could see, I was not doing any extra operations. Is it the most elegant? Not necessarily. Is it possible I do some extra work here and there? It is possible. It's not very likely. I sort of tried to see both memory usage and everything else, but it is possible. So, in some sense, I will be very, very pleased if one of you proves me wrong. This is quite honest. This is not just words. Okay, so let us try. Maybe we do it a little differently. Maybe you will explain my code.
Sure.
Okay. Could we delete the? Are you in Vim?
Yeah.
Could we delete what we started with, so that we don't?
Delete the content.
Delete whatever we started writing. This guy. So, and let us go and see. What is this? All of it. Yeah. We're not going to write it. Param is going to explain it. If he doesn't know, he could say, I don't know, and then I'll help. So he's going to try to explain this stable zero. The stable zero is the one which maintains indices, the one we were attempting to write. Okay? So stable zero, that's the one. No, stable zero. Oh no, stable two. Stable two. I apologize. Yes, stable two. Lo and behold, it does have pair.
You do have a pair type, all right? Okay, so we were at the pair type when we left off.
Yes. So we have pair type.
And then list pool and the operation need to be defined in terms of the pair type.
And look at the line 239.
Compare dereference first.
It used to say compare dereference of compare.
Since our type is no longer dereferenceable, you know.
You have to extract first. So I called it compare dereference first, which you will explain how it works. And then we have compare dereference stable. We have to go and look what that does.
Compare dereference stable.
What do you think it does?
This is the thing that did the comparison.
This is our equivalent of the guy which you wrote called compared dereference random access. This is
Instead of comparing
it's-
pointers, we just
and
do
as we
dot
shall
second.
see, the code is going to be remarkably. Could you show us the code of this guy?
Compare dereference stable. Anywhere where we said x less than y, we're going to say x dot second, and
So that's the only difference.
star x is going to
As
change to
where
star
it
x dot
becomes
first. Yeah.
So it's exactly the same code, and I had to think the same deep thoughts about where it's negation, where it's the.
No, you copy and paste, but you know.
Yeah. But the first time you do it,
You have to think
you
deep
have to
thoughts.
think about it. And in my particular case, it just so happened
You wrote this
that I did
first.
this one before I did the other one. The other one, of course, I did using copy and paste and dropping first. I mean,
Okay, so now that this is clear, the other thing was the compare dereference first. We might as well look at that because it's going to be really simple.
okay.
Yeah, here it is.
Yes. Yeah, it's not very, very profound thing, but you know, it does what it does. It just extracts the first guy before doing the reference.
Okay, now we can go back to stable 0. I guess the only change to the algorithm will be when we, two. When we put things into the pool, we need to attach the index to them. So you've added on line 248 a counter that counts the current offset.
And instead of putting iterators there, I put, you see, I used to put pair of iterator and pool end. Now I put a pair of pair and so it's I mean, it's literally tiny.
I mean, instead of first plus plus, we need to do pair type first plus plus, comma, and plus plus. And that, I guess there are no other changes, are there?
Yes, there are.
Oh, okay. Temp dot first dot first.
There.
Yeah, all of the first and second thing, right?
Yes. We have to do it now. So it becomes temp first. Again, is it possible to write a generic version which will unify it by passing some function of it? Yes, don't do it. In this particular case, cut and paste is the right technology. But again, it's fundamentally, remember we had 4 lines? It's the same 4 lines, the same data structures. So to accomplish stability, okay. So now, Param will bravely explain
The stable
the one which he wants to modify.
Yeah. So I shouldn't discuss my modifications before looking at your code.
Yeah. Let us look at that.
Okay, so the idea is instead of keeping one list, we will keep 2 lists.
But let us see what we do here. Observe that one thing we no longer, we just changed in the previous implementation, we changed I to be a pair. We do not need that. This is gone. We're back to having I and the list in our things.
Don't we need 2 lists?
We do need 2 lists, yes.
Okay, so the list pool is back to its original definition.
Because in the list, we don't need two lists. In the list, we need only, every list just lists the guy who lost
The
to
list is
whomever
just
he
this,
is.
right. But in the op,
So what we did, we need some other op. I obviously did something. Observe that my compared to reference is still the same. I don't need to do anything.
we changed the combiner type, the op min 1 to stable to be.
Yes, yes, we did. And we're going to look at them. Do we look at them? Could you guess how it's going to work?
Again, I don't see right
Why
now
don't
where
show him
there
the
should be
code.
two lists somewhere, right?
What?
During line 17.
Pair of ends. Okay. And okay. So the
That's
counter.
my ident.
Right, you moved your counter, you changed the counter type to have two lists. And,
Yes.
Okay, that makes sense. So then our operation needs to take things
Let's
that
go
are in the
and look at
counter.
Let's go and look at it.
Sure, let's look at it.
And see if we could explain it.
Okay. Has a list pool and a comparator. And
Of course, our indentation collapsed because of tabbing.
what's argument type? Argument type
It's
is
probably defined someplace.
Oh, here it is. Okay, so we have defined an argument type which is a pair of lists. And
Pair of T, whatever it is going to be I, of course. And pair list type.
And we call, okay, so now we should look at combine because that's the, we give it x, y, and who won. Okay, so we've moved the comparison out of the,
No, we didn't move the comparison. We just passed the results of comparison to this guy. So x1 is bool.
Mhm.
So if x1, we do this. Otherwise, y1,
Mhm.
and we do that.
if x1, we free y's list, we free both of y's lists, and then we create a new element, which is the winner. And since x1, the right-hand side guy lost, so we add him to the second list, which is the list of the right-hand people. And conversely, the other side is y1, so we free all of x's lists and add x to the left-hand list of y, which is the first list. So the invariant will be the left-hand list is a list of guys we've lost to in order of in the opposite order.
No, they will be coming in the natural order.
The list itself will be in opposite order.
No, the list itself will be in the right order.
Oh, because we are appending to the beginning. You're right.
Yes.
Yes, and we are getting them in order.
The other guys are coming
In the reverse
in
order.
the reverse order, so they are in the reverse order.
Hmm.
We just will have to do something about it.
Which is why min is going to be more
Min is going to be
complicated
complicated.
No.
for you.
Ty, I'm not going to do any more work, as we shall see. And
Okay,
Yeah,
so
I think, but I'm explained everything
This is
there is.
fairly clear, I think.
It's
The
good.
real work is in the min, I think.
Yes?
So we go back to stable 2. The code itself is pretty much
Stable.
stable. Yeah.
And here we come with an interesting thing, that of course, the main loop is basically exactly the same. Right? Except what we get out, we get min and candidates for the runner-up.
Right, so now we have two lists of candidates.
And here I sort of decided to, I knew that Brian would like it, that I would name them so that people are, we have min element, left list, and right list. And then to get, this is the code. There is just a tiny little cheating there. But the cheating is instructive.
Min element
Of course,
last.
this, for the left list, I just use min element list. It just works because they are in the right order. Now, here I had to introduce a different function, which is very clearly missing in STL, which is a function min element last, never mind list or not. What does it do?
Instead of returning the first, if the two things are equal, we return the second.
Not the second, the last. There could be 11 of
Yeah,
them.
exactly. For two, we return the last one. It's
Yes.
You can think of it as max with the comparator reversed.
Right. Yeah. So I had to write this little function. That I did have to. So your criticism in that sense, but it was instructive because I did realize that occasionally people need additional function in STL, which is min element last. John is going to write a proposal. Standard. All right. So then, of course, I have difficulties. Show him the code. And I don't know what to do about that. Because this is,
If you use my proposal,
I would still have to do some of that.
okay, so let's see what the difficulties are. So I guess the problem is that either of those two lists could be empty,
Or both.
or both could be empty. So we have to handle all of those four cases individually. So if the
This
left,
is this unfortunate reality.
if both the left and the right are empty, why do we return min element twice? Shouldn't we
Because
return
that's what we agreed
last?
upon.
Oh, we agreed upon that
Yes.
in a single element list. Okay.
That's what we're.
The second should be last.
No, that's not what we do in the code before. We could change it throughout, but we have to change it in all of our functions.
It is last because what we ended up there with was an empty list, and we were returning last as the second.
Which one are you talking about? Let's go look. I was positive that that's what we did. Yeah. If is and list temp first. We're returning first, guys.
The
Sorry.
thing we wrote in the class was different, but that's fine.
Okay, it could be changed, from the user point of view. Sort of, if you ask for two guys and there's only one guy, question: do you return first last, or do you return first first? How do you indicate this fact that there is no runner-up? So, right now, I apologize. I thought that we agreed upon.
This is what we wrote in the class that we had last.
Okay. Could be, you realize it could be trivially fixed throughout.
Yeah, this is not a complicated.
Well, it's no. Yes. Yeah. But you think that is a better interface? Why?
Because you're suggesting that the same element is with the,
But at least there is someone. I'm pointing to a value.
if you're the only person in a group and I say you're the best.
I'm the best,
and I
and
also say
I'm the
second
second best.
and
And
third best,
I,
but saying there's a second best implies there are at least two. Saying you're the third best implies
that's
there are at
an
least three.
interpretation. For example, think about what we did with min and max. We returned, if there were one element, we still returned pointers to the same element.
Yeah, if you have a list of one, you have the first is that one, the last is that one.
The last is not an element.
Sure.
The last,
But you, well.
Okay,
I
guys.
agree with the crowd.
I mean, it comes down to
We
what do you
could
assume
trivially,
about-
literally. Okay, Ryan, go and fix it in all 5 places.
It's
No,
trivial to
he
fix,
could do
we
it
know.
within 1 minute.
But we don't gain anything by doing it right now, so let's leave it. So, okay, the other cases are straightforward. If there's nothing on the left, but there is something on the right, we return that. The opposite in the other case, otherwise we need to compare the two, I guess.
Carefully, again, we need to compare.
If right is less than left, then return right, otherwise return left.
Yes.
Yes.
Okay.
Right, I think all of this would be much simpler if we had a pointer to the tail and a single list.
You will write it,
Okay.
and we will post it.
Hmm.
I absolutely think it's important. Again, guys, why don't you create an executive committee? And while I'm away, you come up with the ultimate version of code in this directory. I am not joking. I would be, of course, I reserve the right to review it. But most likely, if you make it better, I'll just say, oh, this is great. Okay? So, okay. So we have only one algorithm left.
I thought we did 4. Okay. Hmm. What's the 4th algorithm?
In your search.
Practical.
Oh, practical. Okay. Yeah, that's very straightforward.
Do
So-
we write it,
Sure.
or do we look at it?
Oh,
Kaiparam, you tell me.
well, we have 25 minutes. I don't
We
know
could
what
write
else
it.
you want to cover in the class.
I wanted to do some experiments. Okay, let me tell you what I wanted to do is how do we know that any of this stuff is stable?
You have to try it out.
How?
Um,
How do you test stability?
We need a type that we can distinguish between identical values, things that are equal, but like if we have used ints.
Couldn't we keep using ints?
yeah, you could keep using an inch. Just you need to know what the leftmost. You need to check your offset when you get your return value. I mean, I've been doing this in the min code I've been writing. I print out both
Isn't
the
that
min and the
an
offset.
Easier way?
You could just use like double or like 11 for the first one, 12 for the second one. Oh, actually, no, I can't.
Guys, there's a very natural way of doing it. You always try to change the type. That requires work and thinking. Leave the type alone. Let it be into whatever we're using it. Change the comparison function. That is awfully easy. And comparison function could do what?
Return the opposite.
And 63.
It could mask part of the bits. For example, imagine what happens if you compare, you have 32-bit ints, but your comparison function looks only at the last 8 bits. 8 bits. Sorry. The least significant. or the most significant, it doesn't matter, but least significant in some sense is nicer. Right? Then what are you going to have? You're going to have a sequence with lots and lots of equivalent values. And then we could see, do we really return
Or do we get the same result?
some same result? Right? So that's, we could actually do this before we write that. Just to, in some sense, we're going to rely on the following thing. We're going to rely on the thing that practical algorithm is absolutely certainly stable, because it just goes to them one by one and absolutely never looks back.
Mhm.
So it is going to do a stable thing, right? Now, if other algorithms return what
What it returns.
it returns,
I think
it's
there's a good
pretty
chance. that
good
they're
chance
stable.
they're stable, because these are million integers. I mean, it's very unlikely that you're going to sort of hit upon, the same thing unless you're.
If you do it a bunch of times with different inputs, then you
Yes.
still get the same
Yes.
answer.
But so I'm just showing you the way. So could we please go to min.cpp?
Do you want to look at the practical algorithm first, or that's pretty straightforward? Or,
We'll write.
oh, you're
But
right.
I want just to show you how to test. Again, I want to leave you in a fairly good shape, that if any of you want to do any work on this, whether Java, Python, whatever, you now have. Okay? So a very simple way of doing it, this is my compare. And observe that this compare allows me to count. This is what I do for counting. Oh, by the way, if you want to do timing, do not use this compare. Because obviously it's doing extra work and you get penalty for counting. But of course, if you do timing, you probably do not need to count. You either count or do timing. So you come here and what do you do?
And 63.
For example.
But wouldn't you make a copy of it and then run it with the normal compare and a regular compare?
We just did run.
Or which is
No.
less, right? Okay. Okay, sounds good.
Right?
Mhm.
So now let us attempt and see again. I want to see the results. What happens? We could have started with 7. Because you're going to, could we do it? No, I mean 63. Could we run it? We'll do it with 7 after. Could just.
How do we know about the right answer?
Let us look.
So
at
0 is the
result.
offset. And what are the two things after results?
Results are the numbers,
Or the two numbers?
the two numbers, which are. So, 0, we know that it has to be 0, or it happened to be 0, whatever in this case. And the second one was 64, which is another 0. But it's the second 0 which happened to be in that randomly shuffled sequence.
Mhm.
A winner and the runner-up are both to be zeros in their first 7 bits.
Shouldn't we print out the offsets as well and make sure the offsets from all the algorithms are the same?
What we know is that this guy, which is unstable,
Mhm.
gave us a different result. All the stable guys returned the same result
How do we know they returned the same 64?
because all the,
Oh, we have unique numbers in this list.
yes, we
right?
have unique numbers.
Okay, that helps, yeah. Okay.
They are
They're unique.
They are unique.
Which,
It
yeah.
is the same 64.
Mhm.
By the way, observe what happens here. The number of comparisons, we actually very quickly that have reached 64 might have been the second number or somewhere. We could find out. It's very easy to find where 64 is. Anybody knows how to find where 64 is? Okay, let us go to the main. We don't need to touch any of this. Or count pardon.
This is
count.
iota, it's not random iota.
Which one?
We're taking them in increasing order.
This is just increasing order, yeah.
Yes? And that explains 64 really nicely, doesn't it? 64 is the second zero in iota.
Right.
Why isn't 1 or 2?
What one? 1 and 2 are greater than 0, yes?
Oh, yes, of course. And
64 is the first
yeah.
0 mod 64. This is what we're doing. We're doing mod 64 by masking this guy. By the way, just to show what happens, let us go and replace 63 with 7. I predict that we're going to get 8. Just
Who wants to bet? $100.
$100, yeah. That, you see, I mean, it worked. Who owes me $100? So, right? We could we probably should switch. Could we switch to
Random iota.
random iota? And this is, by the way, why we got one extra comparison, because it was everybody was losing till 64 came along. That was the only guy who got.
Yeah.
And from that point on, we were rejecting everybody else.
Yeah, it's still consistent.
No, there you go.
No.
Oh,
This,
we're still doing
Mod
the
64.
first
Mod
guy
7.
is always the same. It has to be because we are stable on the winner.
the still modding.
Right. We're still modding on 2 or something. 7, whatever. All right?
All right.
Okay. Now let us go and write. Panoramas is really keen on writing this guy. Now let him give him a chance.
No, I'd be happy to just look at the code, but whatever. Make a copy of min and call it min 2 practical.
Yeah. Mean 1, 2 practical. Yes. You know the name. Mean element 1, 2 practical. And you probably want
No, you don't want this
practical.
one. You don't want this one.
Oh, you want that one. The signature is exactly the same.
Okay, fine.
The code you throw away anyways.
Okay.
But you don't say class. Why did you say class?
So it will still compile.
Or because saying to the same name, thank you very much. Just. Okay.
Why did we say class?
It's the one we do in the class.
I see.
Element of the same name.
Okay, got it.
I didn't understand the diagram.
Yes.
Maybe it should be lecture.
Well,
So if first equals last, return make pair, standard make pair, last comma last. All right. I space min.
Let me give you a simple suggestion. I really would special case also the case when we have one element.
Yes, so I min equals first plus plus, plus plus first. If first equals last, return standard make pair min comma min. Enter, plus plus first, I min 2 equals first, min 2.
Min 2.
Oh, wait a minute. Okay, now we need to start comparing, right? Or do we need to start, should we start the loop right away?
I would recommend before you start the loop, you do something. Because, you say that first is mean and the second one is second,
Should
but
probably
you really
compare.
have no evidence for that.
Yes. So if,
What is it about?
You already implemented first. Oh, you got the one coming
What? No.
in. Yes.
No. No.
You incremented here.
we
Yes,
already,
And
no.
You didn't save off first anywhere. You didn't save it off until you did this.
Yep.
No. But min 2 is this first. Is first this. After you do first increment. Is the second
But-
element.
But this is being incremented twice. You're incrementing here and you're incrementing here.
yeah, the increment needs to be after the declaration. Yes, absolutely.
Okay, this is what needs to be. Yes, I did. Okay. But before you increment it, I would do something.
Right. If min 2 less than, and I would just say min 2, the numeral, rather than underscore TWO.
What's that? Oh.
Yeah.
He knows about digits. He comes from the country who invented them. After all.
Yes. If min 2 is less than min, compare. Okay.
I wouldn't do that. Yes. And no, I wouldn't do that. I just wouldn't do it. Computer will melt. There will be terrible noise.
Okay,
and
star.
stink.
Star.
That is better.
Star min 2, comma star min. Swap.
Yeah. Why
Standard
not?
swap. Min, comma min 2.
We're done with that. Now we know that min is really min.
And min 2 is really min 2. Okay, so now while first is not equal to last.
You never need to think. That's always what you write. I told you that's what has to be engraved on my tombstone.
While first is not equal to last. All right. Okay, so first we compare the next guy to min 2. So if compare star first, comma star min 2, then he has a short. So, then if compare star first, comma star min, then min equals first. Oh, sorry, min 2 equals min, and min equals first.
Very good. Otherwise,
Yeah. And then else min 2 equals first. And then we return, outside the while loop, return, oh wait, increment first somewhere, yeah, here. Plus plus first, return standard make pair min comma min 2.
it's pretty good. Very impressive. Not a single glitch.
I ask this thing in interviews, so.
No, but I mean, come on. That's very impressive.
On line 57, shouldn't the comparison be other way around, min and min 2?
If they are out of order, then swap. That's what he says.
But if they are equal, compare will return min 2, right?
If they only, he will swap only if it's strictly less. Remember, our operation is strict. Therefore, if it's equal, compare returns false. Therefore, the swap will not be done.
What about 60 and 61?
Yes?
Same thing,
Same
if the
thing.
current element is strictly less than what we have, then we swap.
It's only if the new kid wins, he has a chance. Right. We're always strict on the new kid. Now we test it. Okay, let's see what I did.
All right, let's compare.
Here we will see some discrepancy. And of course, it's totally identical here, up to this line 307.
Compare deref.
Well, first of all, I use compare deref not to muddle with dereferencing. Since I already created this helper, I might as well. You could have used it too.
Right.
But I decided
Insert.
to invent this thing called insert to, which does, we're going to see it, this. Basically, if you have 1, 2, 3 guys, it does insertion into the pair. I thought it might be handy someday. But if you think about it, it's identical code.
It's the same.
If we move it in. So, I'm not, this was touch and go, but I thought it could be useful in the future.
Could be.
So, this is why I did that. You see, it's identical to Perhaps code. You know, again, candidate comes on the
Replace star
left.
first with candidate, everything else.
Yeah. And since I don't need to do dereferencing,
Mhm.
because I use
Yeah.
compared reference. Because I wanted to write this, I didn't want to write this guy in terms of iterators, but in
Mhm.
terms, because,
In terms of the values, yeah.
so just, but I would claim identical. Let's test his, but we could test his by going to min.cpp and adding just one line.
Copy, yeah.
Did you check? You have to, no, you have to
You
change.
fixed it in the other place too.
No, but you didn't fix the name.
Changed.
Just to make it professional. Because unless I print the name of an algorithm in tests, it's always confusing. I forget in which order they come.
Is it practical lecture?
What happened?
It's not called lecture, it's called practical lecture.
Then, just for my benefit, yeah, thank you.
Compiles.
Well, if they do differently, no. Fortunately for us,
Returns the same thing. All right.
they do the same things. By the way, a very good way of testing sort of algorithms is comparing the results of two different algorithms. Because the likelihood, say, if you sort million elements with quicksort and with heap sort, and they sort, they produce identical result, likely both of them are correct. All right, guys, we are done. So I urge you to consider participating in some of these projects, and I will be waiting emails. Next week I'm away. Do not send me. Oh, send me emails. I'm not going to read them. I don't check work mail at home. In case you, by the way, want to reach me, you send me to my home email, which is stepanov@gmail. So that I do read. But the week after next, I'm expecting lots of messages from all of you, improving this code, Python code, for sure, like at least some people here know Python. But you know Python.
Yeah.
So, trying to find, again, I talked to Ryan about it. The idea is not to show how bad Python is, quite the opposite. Find the most Pythonic way of representing these algorithms without sacrificing at least asymptotic complexity. If you see what I'm saying. You still should be careful about using extra memory,
Same
amount of additional memory.
comparisons in
Right.
Yeah.
So trying to maintain the algorithmic structure in a Pythonic way, or in Java. Anybody knows any other languages? People are silent. People don't want to write code. You know Lisp.
Yes.
Why don't you try doing it in Lisp?
Okay.
No, I mean, it should be relatively trivial, or Scheme, whichever you prefer.
How I go?
Why don't you try to, I mean, I don't know Go. Do you know Go?
No, I want to learn.
Okay, by the way, doing that is a very good way of learning Go, or any other language. Okay? No, anybody knows Prolog? No, I don't want to say. Let me tell you, there are certain limits. I could program in just about any programming language except Prolog. This I just can never figure out. This is not, I don't think like that. They think it's a very natural way of thinking. I find it utterly unnatural. But I have
It takes a
different.
couple of weeks, and then you start thinking like that.
No, not for me. I just don't think like that. Lisp, very natural. Even Java I found relatively natural, but
Prolog.
not Prolog. But if anybody knows Prolog?
15 years ago, I knew a little bit.
Try doing, look, I think it's a good thing. We finished certain algorithmic spaces of class, right? It's a very small space, but in this small space, we were pretty exhaustive. We covered all versions. Trying to do it would be very helpful. Prolog is not Haskell would be, of course, more interesting. Maybe all will do Haskell. Would you like to volunteer?
I'm not sure. It's.
But I think just having side by side different implementations and very good implementations, the whole idea, and somebody should, or all of you should try to improve this code, which we will post now. Okay, bye.